Hello guys, welcome back to my YouTube channel. First of all, happy Diwali to all of you. So now we are going to solve problem number 2463, minimum total distance traveled. So actually we are expecting easy problem today because of festival, but this is not in our hand, right? Okay, so let's read the problem statement first and let's make this problem a little bit easy. Okay, so there are some robots and factories on the x-axis. You are given an integer array robot where robot of I is the position of the ith robot. Okay, clear? You are also given a 2D integer array factory. Factory of j is representing total two values. One is position and one is limit. Position of j is the position of the jth factory, and that the jth factory can repair at most limit of j robots. Okay, so this is given to us. The positions of each robot are unique. The positions of each factory are also unique. Okay, note that a robot can be in the same position as a factory initially. All right, all the robots are initially broken. Okay, they keep moving in one direction. The direction could be the negative or the positive direction of the x-axis. Okay, when a robot reaches a factory that didn't reach its limit, the factory repairs the robot and it stops moving. Okay, at any moment, you can set the initial direction of moving for some robot. Your target is to minimize the total distance traveled by all the robots. Okay, we have to return the minimum total distance traveled by all the robots. Okay, the test cases are generated such that all the robots can be repaired. Okay, and these are the important points. All the robots move at the same speed. If two robots move in the same direction, they will never collide, right? If two robots move in opposite directions, they meet at some point, they do not collide. Okay, they cross each other. All right. Okay, if a robot passes by a factory that reached its limits, it crosses it as if it doesn't exist. Okay, if the robot moved from one position x to position y, the distance is going to be the absolute value between them. Okay, x to y, so y minus x absolute value. All right, so here see this example number 1. A robot is at position 0 4 6, 0 position, 4 position and 6 position. Okay, and we have factory at 2 position and limit is 2. Okay, this value is nothing but limit, so this factory can fix total 2 robots. This factory at position 6 can also fix 2 robots. Okay, so here I can say one thing here. Let's sort them. Okay, let's sort them, my robots and factories, based on their position. Okay, if I sort them based on their position, then definitely the robots is going to cover less distance. Okay, to get themselves fixed, right? So sorting is the best thing here, because I want minimum distance between them to get fixed. Okay, so if I sort them, so definitely this robot will come to its nearest position. Okay, so here let's say this is one line. Okay, so my robot 0 should come first, right? And then my robot 4 will come. Okay, and then my robot 6 will come. This is already sorted in this example, but in some other examples where it is not sorted. Okay, so I have sorted the robots based on their position, and let's sort factories based on their position as well. So this factory is at 2 position and this factory is at position 6. Okay, already sorted, but let's write it here. Okay, so 2, okay, and we have 6. All right, so I can say one thing. I can write 2 2 times. Okay, let me write 2 2 times, because this factory can fix 2 robots. Okay, if okay, and this 6 2 times. Here in the line you see some distance, but there is no distance. Okay, let's say these two things are parallel. Okay, so 2 2 I'm writing 2 times, and 6 6 I'm writing 2 times. Okay, okay, so here why I'm writing 2 2 times and 6 6 times, because let's say if 0 is getting fixed with this 2, so I removed this 0, I removed this 2. Okay, now this 4 has the option to get itself fixed from 2 or 6. Okay, so I can let's say this 4 is getting fixed with 2. Okay, so here if 0 get fixed with the 2, so absolute distance between them is 2 minus 0, which is 2. Okay, and if 4 is also getting fixed with this same factory which is at position 2, so again 4 minus 2 is 2. I need absolute only. Okay, then this 6 can get self fixed from any 6. Okay, So if this 6 get fixed with this 6, then absolute difference between them is 0 only. 6 minus 6 is 0. Then in the end there is still going to be remain one factory with the 6 value, right? So here all these are removed. Okay, all this stuff is removed. Still one factory is left with 6. Okay, so that is simple meaning I'm writing here 6 two times. Okay, so that this becomes a little bit easy, right? So now there is 1 6 value left, still left. Okay, so that's the reason. So here you see the absolute distance 2 2 4. 4 is the output, right? So the first robot at the position 0 moves in the positive direction. It will repair at the first factory. The second robot at the position 4 moves in the negative direction, and it will be repaired at the first factory itself. That's what we did here, right? The third robot at the position 6 will be repaired at the second factory. Okay, this is first factory and this is second factory, right? uh, the limit of the first factor is 2 and it fixed 2 robots. Okay, that is why I did that. The limit of second factor is 2 and it fixed 1 robot. Okay, so here 2 minus 0, 2 minus 4, 6 minus 6, 4. Okay, that's my output. Okay, simple thing. So that's what we need to do. Okay, so I hope that you guys are clear with this example. Okay, so now how we can solve this problem. Okay, so there are many ways in which we can solve this problem, but first let's try to solve it using recursion. Okay, so here this robot wants to fix get itself fixed. Okay, so this robot has two options now, whether he wants to fix here or whether he wants to skip this factory and move to the next one. Okay, these are the two different options we have. Okay, so, but let's do few things first. Okay, that I did here. Sort them based on their position and make them like this 2 2 6 6. Okay, so let me write the code for that one. Okay, so here we have to sort my robot and my factories. Okay, so here what we need to do, so this robot is a list of integers. So here I'm just going to write collections dot sort and I'm sorting what robot. Okay, this is one thing. And now sort the factory. Okay, so arrays dot sort, but I'm sorting what, I'm sorting factory, right? And how I'm sorting them, I'm sorting them based on their position, and position is written at the first index. Okay, a of 0, let's say. Okay, so here what I'm going to do, I'm going to use comparator dot comparing int. Okay, and here based on their first index, so here I'm going to write a of 0. All right, this is done. Okay, so now after that we are going to flatten factory positions according to their capacities. Okay, simple means that 2 I have tried 2 times, this 6 I have tried 2 times. Okay, limit is 2. So this is what I need to do. So here list of integer, and here I'm going to write factory positions is equal to new array list. Okay, and here for I have to iterate over all these factories one by one. Okay, so this factory is nothing but a 2D array. Okay, so first I need to iterate over this one array. Okay, this one array, and it is a complete 2D array, right? So here int, and here let's pick first array. Okay, from my factories. Okay, so here factory factory pick. Now what I need to do, I need to write this total 2 times. Okay, so here this is nothing but f of 1. Okay, I pick this f, this complete factory. From here I pick this array f. Okay, and f consisting of 2 values, so I am going to iterate this many times. So here I'm going to write inside this for int I is equal to 0, I is less than f of 1, and here I plus plus, and then after that I am going to add these positions in my list of integers array list. Okay, factory spelling mistake, positions. Okay, dot add, I'm adding what, I'm adding this 2 times, I'm adding this 6 2 times. Okay, so here f of 0. All right, done. Clear. Now here this for loop ends, Now what is the total robot count that I have robot count is robot count. Okay, let's create this variable, and the robot count I will get from this list. So to get the size of list, we have to write simple thing robot.size. Okay, and how to get number of factory positions? So we have 4 factory positions, right? 2 2 6 6, 4 factory positions. Okay, so here in this, from this I get the size, right? So here int factory count is equal to factory position dot size. Okay, I hope I'm not doing any spelling mistakes. Okay, we'll see in the end. Okay, now recursion definitely solution will not be accepted without doing memoization. Okay, so let's do the memoization side by side. So here create one 2D array, let's name it as memo, and here new long, and in my recursion code only two things are going to change every time. One is uh, robot counts, okay, robots position, and factory position, okay, which factory I want to use. Only two things I'm going to change. So let's add here inside this robot count, okay, and factory count. Okay, this is done. All right, now here do one thing. Let's fill this memoization array with -1 initially. Okay, all the values I'm filling with -1. So here long, and let's iterate over every row one by one in my memo, which is 2D array. Okay, so in each row I'm going to fill array.fill each row with the value as -1. Okay, this is done. So later on we will see if there is any value which is not -1, then that means that we have calculated this in past. Okay, then after that we have to recursively calculate the minimum total distance with memoization. Okay, so in this function simply I'm going to return calculate min distance. Okay, and here I'm just going to pass 0 0, and here I'm going to pass robot, here I'm going to pass factory position, and here I'm just going to pass memo. Okay, this is done, right? So here what is this 0 0? So this 0 by 0 is nothing but, I can say that this 0 by 0 is nothing but my robot index. Okay, this is nothing but my robot index, this is nothing but my factory index, this is the list of integers of robot that I have, list of integer of factory positions that I have, and this is memo array. Okay, so this is done. Okay, so here let me just, okay, it looks good. So now let's just define this. Okay, so it is going to give me this value. Okay, so can we define it here? Let's define it here after this. Okay, all right, this is done, right? So now here write private long calculate min distance. Here I'm just going to find pass robot index, and then after that I'm just going to pass factory index. I'm going to pass a robot. Okay, so here a list of integer of robots that I have, and I have already sorted them, right? Okay, this is one thing. Factory position I have to pass, so factory position will come from here. Here I have added all the factory positions, and I have to pass the memoization array. So this is my memoization array. Okay, so all these things I have to pass here. All right, now once this is done, now after that inside this we have to write if my all the robots are assigned. Okay, so few base conditions. If all robots assigned, so if all robots in assigned simply means if my robot index is equal to robot dot size. Okay, so in that case simply return 0. Okay, if all the robots are assigned. Okay, if no factories left to assign, this is also one base condition. Okay, if no factories left to assign, then this is also one base condition. So here you can simply write if factory index is equal to factory positions dot size, factory positions dot size. Okay, then in that case you can simply return long of here 1 par 12. Okay, 1e12 you can pass, right? So for memoization, okay, check memoization. I'm going to check. So if this value is not -1, then definitely means that I have calculated that value in the past. Okay, so here I'm just going to pass if memo of, and I told you that only two things are going to change every time. One is my robot index, which is going to update every time, and one is my factory index, which is going to update every time. Okay, so if this value is not equal to -1, that simply means that I have calculated this in past. Okay, so here inside this I'm just simply going to return this value, memo of robot of index and this factory index. Okay, this is done. Now let's see what we need to do. Okay, so we have two options now: assign current robot to the current factory. Okay, so this is going to be option 1. Option number 1, assign current robot to current factory. Okay, and here if we are assigning, so long assign. So how I'm going to assign? Okay, if I'm assigning, so I'm assigning like this now. So for assign, what we are doing, we are assigning, let's say, this to this one, and then for next robot we are starting from here. Okay, so this is one option for assign, and for skip we are directly starting from here. That's what we are going to do in the code. If I'm assigning, so here I'm just going to write math dot absolute of robot dot get robot index. Okay, idx. All right, and here absolute I'm doing, so here factory positions dot get, and here I'm just going to pass factory index. Okay, and this is what I need to calculate, and for the remaining portion I'm just going to call this calculate mean distance again. Okay, calculate mean distance, I'm calling it again, and here instead of 0 I am going to pass robot index plus 1. Okay, this is what I'm doing, and I'm updating my factory index. Okay, if I'm using that, so I'm going to update my factory index as factory idx plus 1, and I'm passing same robot factory positions and memo. Okay, this is done. This is the first option, and option 2 is to skip that. Okay, so option number 2 is skip current factory. Okay, skip current factory for the current robot. Okay, so here simple thing we have to do, we have to write long of skip. Okay, so here let's write long of skip is equal to calling this again calculate mean distance, and here robot index. Okay, it is not going to update, and I'm going to update my factory index to plus 1. Okay, factory index plus 1. Okay, robot this. Okay, and this is what we need to do. Okay, two options: assigning the current report to current factory, or skip the current factory for the current robot. Okay, then after that we have to take the minimum and store in the memo. Okay, so memo of, this is what I need to update, right? Memo of robot index, this is what I need to update, and I'm going to update that with the minimum value that I'm going to get, math dot mean. Okay, and here I'm just going to pass my assign and skip. Okay, this is what I need to pass, and from here I'm just going to return memo of this one. Okay, so that's it. Okay, so now let's try to run it and see if there are any code issues. Okay, so here arrays, it should be arrays now. Let's run it again. Okay, so now line number 17, line number 30 we have issues. Okay, let's see that and fix that. Line number 17, return calculate. Okay, so here what I'm doing, return calculate mean distance 0 0 robot factory position. I'm writing it's factory positions, right? Factory positions, and here it's memo. Okay, so same thing, right? I think I am doing here as well. Factory positions should be there, right? And here also it should be factory positions. Okay, let's run it again and see. Okay, so let's see what is the issue now. So here we are getting -1, but expected is -4. Okay, so let's see. Here not 1, here it should be -1 now. Initially I set a value to -1. If it is not -1, then this should happen. Okay, so I think this is a issue. Okay, so the test cases has been accepted. Now let's submit it. Okay, so see, our solution is accepted, right? So this is the recursive approach. Okay, so using this recursive approach we can solve this problem, right? Okay, so now let's move to the DP solution. But if you guys are good with the recursion approach, then you can skip that. But if you want DP solution, then let's get started with this one. Okay, so here's same thing. We are going to sort our robots array. Then we are going to sort the factories based on their positions. Then we are going to create the factory position. Okay, code is going to remain same here as well. And robot count, factory count, I will use that as well. And here, okay, so from here I don't need this stuff. Okay, so let me just remove this. Okay, and okay, so until here I'm removing it. Okay, so here this is ending here, this is ending here, this is ending here, and we need one more vector right here. Okay, so now I'm just going to do some little bit modifications in this DP code. Okay, so let me just format it. All right, now it looks good. Okay, so this is ending here, this is ending here, and for this ending here, this ending here. Okay, so now here I'm going to write the DP code. Okay, so here what I need to do. Okay, so here same thing, right? What we did, 0 4 6 sorted them, and 2 times we have to write, and 6 2 times. Okay, so this is clear until now. Robot count, we get robot count here is 3, and here factory positions count we are taking, and that is nothing but 4. Okay, so after that what we need to do here, we have to use total 2 arrays. Okay, so instead of using 2D DP array, I'm going to use a single 1D. Okay, so long next I'm going to use, and long current I'm going to use. Okay, so in the long next, okay, so here what I'm going to do, new long, and here I'm just going to pass a size as, I'm going to give the size as factory count plus 1. Okay, factory count, 1 second, it is not copied, I think. Factory count plus 1. Okay, and just copy it and paste it here as same size. Okay, so this is what I'm doing here, right? So we are making next, we are creating one next array and one current array. Okay, so here I'm giving them the size as factory count plus 1. So factory count here, this is nothing but my factory count, right? Size is 4, so 5. 5 size. Okay, so 5 why, because it's starting from 0 and x, right? 1 2 3 and 4. Okay, this is what I need to do here. Okay, 0 1 and 2 and 3 here and 4 here. Okay, so this is nothing but my next, and this is nothing but my current. Okay, so initially let's do one thing. Let's fill them 0 0 0. Okay, let's fill 0 0 0 everywhere. Okay, do this. Okay, by default it's 0 only. Okay, and here once this is done, okay, then after that in our code what we need to do, so I'm going to fill the DP table using 2 rows for optimization. So here I'm going to run one loop for let's do one thing now. Let's do it like this, code like this. Okay, for here inside this I'm going to write int I is equal to robot count, the robot count that I have, and in this I'm subtracting 1, and I should be greater than equal to 0, and here I minus minus. Okay, and now here after that no factories left case. Okay, so here just write like this, no factories left case. So here if in the starting if my I is not equal to robot count, so for the first case it is not going to be the case. Okay, robot count minus 1. Okay, if I is not equal to this one, then in that case just set this next of factory count to the long size of 1e12. Okay, 1e12. Okay, this is we have to do when my I is not equal to robot count minus 1. But here initially we are starting from here only, so in that case this is not going to be updated, right, next to factory count. So factory count is nothing but 4. So next to factory count I'm not updating it to the max value, this value 1e12. Okay, so initially it is going to 0 only. Okay, so this value is 0 only initially, so there is no change here right now, right, because my I is like this only. Okay, so this is the case if my I is not equal to this one. Okay, when no factors left case, something like that you can write. Okay, so here this is useful for this main case. Okay, for this particular in this case, but here just understand it like this, initially it is not there, so I'm not updating it. Okay, so now after that inside this what we need to do, so here I'm going to initialize control. So my current of factory count, factory count, and I'm going to update this to long of 1e12. Okay, so here current I am updating it with 1e12, so here I am updating this 1e12. Okay, this 4. Okay, so now what we need to do, I'm starting from here. If you see my I is robot count minus 1, so robot count is 3, 3 minus 1 2, so this is 2 index na? 0 1 and 2, so I'm starting from here. So here what I am seeing that I want here, I want to see if I can assign this here or skip it. If I assign this here or skip it, if I assign this here or skip it, if I assign this here or skip it. Okay, these two things that I need to check. Okay, so for this particular I have to check all these j positions, which is nothing but 0 1 2 3 index. Okay, until here. So until here I have to fill for this particular robot. Okay, first I'm filling this one. Okay, so here what I'm doing after that, for int j is equal to factory count minus 1, factory count minus 1, and j is greater than equal to 0, and j minus minus 1. Okay, this is what I'm saying now. For all the values I have to check. Okay, for all the j's. Okay, so if I assign current robot to the current factory, so here I'm adding one comment, assign current robot to current factory. Okay, so long assign is equal to math dot absolute of. Okay, so here if I'm assigning this at this position, so I have to check the distance only now. 6 minus 6 absolute difference is 0. Okay, if I'm assigning right. So here long math dot absolute of long. Okay, now see how I'm calculating the absolute difference. Robot dot get add I minus factory position. Okay, positions dot get I. Okay, get j, sorry, j. Okay, so absolute difference between them assigning, and here in the plus I'm just going to add next, okay, which is going to store the values for the previous robot iterations, okay, j plus 1. So add next of j plus 1. So this is what I'm going to store. So initially this is 0 only, okay, this is 0 only, j plus 1, okay, for this one j plus 1 is 0 only. So here that is why you are going to see this assign as 0. Why 0? 6 minus 6 is 0, absolute difference. And then in this I'm adding this next of j position, okay, 0, which is why I'm getting 0, okay. And if I'm skipping this, so in skip case I have to take this value as here only, which is nothing but 112. So here skip, uh, let me add the comment, okay, skip current factory for this robot, okay. So long skip is equal to current of j plus 1. This is what I need to do, okay, done. And then we have to take the minimum options always, okay, take the minimum option. So here I'm just going to take the minimum option between the sign and skip, take the min option, and here I'm just going to update my current of j as math dot min between assign and skip, okay. These two things we have to do, okay. So this is what I'm doing inside this for loop, okay. So what I'm doing, so here I'm going to update it with 0, assign 0, okay, and skip is I'm getting this right. So current 3 is I'm setting it to 0. Same way I want to see if I want to place this 6 with this 6, okay. If I place this 6 with this 6, okay, then 6 is assigning, okay. So 0, okay, and here I'm getting 0 only, 6 minus 6 0 only, and next of j plus 1 is also 0, so here 0, okay, and skip is also 0. So current 2 is also going to remain 0, okay, here it also going to remain 0. Then I'm going to check the factory at 2, okay, this same robot with the factory at 2, okay, this one factory at 2 means this one. Then for this factory we have to check, okay. So here 6 minus 2 is 4, in the signing case 4, and next of j is 0 only, right. So here I'm going to update this to 4, and minimum we have to take minimum, so 0 0. So in the end my complete current after processing robot 2 with this robot is going to is this, okay, 0 0 0, and here this 1e12, okay. Then after this is going to become my next, okay. Once this is done, this is going to become my next, and then I have to again calculate the current, okay. This is what I need to do, okay. So here once this is done, then here we have to move to the next robot. So how I'm doing, I'm going to copy. So here system dot array copy, okay, and here after that current, I have to copy current starting from 0 to my destination which is next, and I'm start copying from 0, and the site factory count plus 1, okay, factory count plus 1, done, okay. So this is what we need to do, okay. And here in the end we have to just return current of 0, okay. So now I will explain the dry run, I will do the dry run, okay. I will show you. So let's run it and see if there are any code issues with this. So yes, okay, so let's fix them. Line number 23 I'm getting some issues, right. Line 23, so let's see. Assign is equal to long assign is equal to math dot absolute of long robots dot get I minus factory positions dot get of j plus next of j plus 1, okay. What is the issue here? 1 second. Variable robots, what is the variable then? Robots, robot I'm using here, it is robot, okay. Okay, so it's robot only, right, not robots. Let's run it. Good. Okay, so all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? So here, this is a complete dry run, okay, for this example. Then we are resetting next factory count for next robot, okay. So for the next time, I'm going to set this to 112 only, okay. Then again, I'm going to process a robot at index 1, which is position 4, okay. And then after that, again, if I assign it factory at 6, if I assign it factory at 6, I factory at 2, factory at 2, and I will get the current values, okay. So after that, again, I'm going to change this complete to next. Then I'm going to reset, and again I'm going to start for this one, okay. This is what we need to do, and in the end, at this position, I will get the total value, okay. So this is the output for this one, okay. I have added the debug statements, so with the adding the debug statements, I'm getting like this, okay. So this is the procedure that is happening, okay. So this is the example you can follow, okay. So these are the robots, and all the robots have one limit, okay. So just uh, try to solve this problem, okay. Just refer this code, okay, this dp code, and you will just go over these statements one by one and try to solve it, okay. So do all the things, okay. Sort them based on their positions, and then try to start the processing from this robot, then this robot, okay. So here for index 3, position 101, then locate that, okay. This is the current that you guys are going to get for the first iteration. Then the next state, okay, current, copying the current to the next. Then I am going to reset next factory count for the next robot, okay, with the max value 1e12, okay. So again, I'm going to get start, okay. So this is a complete debug statements, okay. This is a solution with the debug statements, and in the end, at this index, you will get the output, okay. So just try to do the debug, uh, try to solve this problem, okay. Take copy pen pencil, okay, and take this example, open this code, okay, and then try to solve it and go over these statements one by one, okay. You guys will be able to understand this, okay. So this is the dp solution for this one. So I hope that you guys are able to understand today's problem about the approaches, recursive and dp one, okay. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.